The latest development in textiles and fibers is a kind of soft hardware that you can wear, cloth that has electronic devices built right into it. Researchers at MIT have now embedded high-speed optoelectronic semiconductor devices, including light-emitting diodes, that is LEDs, and diode photodetectors, within fibers that were then woven at Inman Mills in South Carolina into soft washable fabrics and made into communication systems. This marks the achievement of a long shot goal of creating smart fabrics by incorporating semiconductor devices, the key ingredient of modern electronics, which until now was the missing piece for making fabrics with sophisticated functionality. This discovery could unleash a new Moore's law for fibers. In other words, a rapid progression in which the capabilities of fibers would grow rapidly and exponentially over time, just as the capabilities of microchips have grown over decades. Optical fibers have been traditionally produced by making a cylindrical object called a preform, which is essentially a scaled up model of the fiber, then heating it. Softened material is then drawn or pulled downward under tension, and the resulting fiber is collected on a spool. The key breakthrough for producing these new fibers was to add to the preform light emitting semiconductor diodes the size of a grain of sand and a pair of copper wires a fraction of a hair's width. When heated in a furnace during the fiber drying process, the polymer preform partially liquefied, forming a long fiber with the diodes lined up along its center and connected by the copper wires. In this case, the solid components were two types of electrical diodes made using standard microchip technology, light emitting diodes LEDs and photosensing diodes. Both the devices and the wires maintain their dimensions while everything shrinks around them in the drawing process. The resulting fibers were then woven into fabrics which were laundered 10 times to demonstrate their practicality as possible material for clothing. One of the advantages of incorporating function into the fiber material itself is that the resulting fiber is inherently waterproof. To demonstrate this, the team placed some of the photo-detecting fibers inside a fishing tank. A lamp outside the aquarium transmitted music through the water to the fibers in the form of rapid optical signals. The fibers in the tank converted the light pulses so rapid that the light appears steady to the naked eye to electrical signals, which were then converted into music. The fibers survived in the water for weeks. Though the principle sounds simple, making it work consistently and making sure that the fibers could be manufactured reliably and in quantity has been a long and difficult process. The first commercial products incorporating this technology will be reaching the marketplaces as early as next year. These initial applications will be specialized products involving communications and safety. Beyond communications, the fibers could be potentially have significant applications in the biomedical field. For example, devices using such fibers might be used to make a wristband that could measure pulse or blood oxygen levels, or be woven into a bandage to continuously monitor the healing process.